Hello students, in this video we'll see two examples of using continuity along with density to prove that two functions coincide. Let's suppose, in the first example, suppose that f and g are continuous mappings of R to R, such that f of q is equal to g of q for every rational number. Then f of x is equal to g of x for all real numbers. So if two functions coincide on the rationals, they have to coincide everywhere by continuity. So how do we prove that? And this is the first application of density, so the proof is relatively straightforward. Proof by the density of Q and R for any zeta, which is irrational. There's a sequence of rational numbers that converges to zeta. There is sequence Qn in Q such that f of Qn such that Qn converges to zeta. So let's write that out. So Qn converges to zeta such that Qn converges to zeta. Okay? Now we know that f of Qn is equal to g of Qn. Okay? Good. So that's because they coincide where? We know this is true for every rational number, right? For every rational number q. All right, so now, by continuity, we have that f of Qn converges to f of zeta, and g of Qn converges to g of zeta. But these sequences are the same sequence. Those sequences are the same sequence. So the conclusion, therefore, is that the sequence converges to f of zeta and g of zeta by uniqueness of limits. We have that f of zeta is equal to g of zeta. And that's the proof in this case. Let's see another sort of problem in a similar vein. Let's suppose that now, similarly, assume that for any alpha in R and beta in R, there's a gamma in between alpha and beta. Let's assume without loss of general that alpha is bigger than beta, alpha and beta, such that f of gamma is equal to g of gamma. Then f is identically equal to g if f and g are continuous. Okay, same setup as before. Now, I'm not saying they're agreeing on the rationals. I'm saying that between any two real numbers, I can find a point in between any two real numbers where the functions agree. It's equivalent to the same sort of idea of density, right? This is a sort of akin to a density argument. And so what I'm going to do is the following. I'm going to consider, let x be in R. And then I know there is Cn in the interval x to x plus 1 over n. My two real numbers are now x and x plus 1 over n, such that f of Cn is equal to f of Gn, with f of Cn is equal to g of Cn. But now, of course, clearly this sequence of points, Cn converges to x by the squeeze theorem, right? So Cn is going to converge to x, clearly, converges to x. And these sequences are going to converge, therefore, by continuity to f of x, and this converges to g of x. But again, by uniqueness of sequences, those things are equal. So there's another example of a density-style argument that shows that two functions that agree on a certain prescribed set have to be equal everywhere using density and continuity. Thank you very much.